Great, we have this program now that returns a value from a word that we put. So it returns the definition of that word, and it also counts for non-existing words in our dataset, which is data.json. To count for different cases of letters that the user may input, you may look at the dir str should show you the methods that you can apply to a string. And here is there's a lower method, and what that does, is if you put rain there, it's so the method should be applied with brackets. You get rain, so the lowercase version of the letter. So since our data are all in lowercase in our data.json file, then what you do is, as soon as you get the input here, the string, you can convert it to lowercase, and then you pass that version to the dictionary access expression in here. So that would be something like, w equals to w.lower. So we are updating the w value here, the string that the user inputs, and then the w here will be passed as lowercase. So as easy as that. Let me do a quick test. Rain, and you get the correct definition of rain. So let's think about more possible values that the user may input. Let me clear the command line so you see better. Let me call the program again. Weather works fine, but how about instead of putting rain, the user types in an extra n there. The program says the word doesn't exist, which is true. But as a programmer, you want to make your program as more intelligent as you can. So in that case, you may want to consider checking for strings that are similar to what the user input. Rain, you need to check if there is some string that is similar to this word. And instead of saying the word doesn't exist, you want to suggest the user that, maybe you meant this word, similarly as you do a search on Google. So that's a bit complex, but not that much. And I'll show you how to implement that in the next lecture, step by step. So see you there.